Welcome, everyone. Welcome back. And you can tell I'm Inslee, right? No, I'm not. I'm Raymond. I will be your host right now for this session. My name is Raymond Lowe, OpenVINO Evangelist. Remember my name because you're going to ask me a lot of questions in the Q&A today. You see this laptop here? This is where I will be talking back to you. So first thing first, does anyone know what's NLP here? If not, oh, today is your day because it's one of the hottest topic for AI. And very luckily, we are bringing one of the experts from PRC to talk about this topic. Hi, Dr. Wu.
Hi, Raymond. Hello, everyone.
Yes. And Jo, I'll say that's her name as well, is our evangelist in China. So if you're watching globally today, you notice our Intel AI evangelists are everywhere. Well, to get to the point, today's topic is about NLP and AI and how we're going to use something called dynamic shape. These new features sounds like a myth to you, but we're going to talk about it so that you understand how to use it. So how about right now, let's have a quick question about what's NLP exactly? We'll talk NLP. What's NLP?
NLP is actually natural language processing.
Yes, and what's it used for? I think that's where the presentation gets started. How about I'll give you now the start.
Okay, so yeah, let's first take a look at where actually do we use NLP. Actually, I think we can see it being used every day in our daily life from, chatbots when we want to ask questions for the machine to provide us answers, So, for example, in the healthcare industry, that when doctors sometimes use NLP to extract key information from the medical records from the patients, and then they can restructure the information into the formats they require, and so that it could be easily digitized, stored, and also be used for further analysis and be very convenient for search for further information. So actually, and also I think in search engines and in automatic document processing for insurance industry, for banking, all those scenarios you can see, we actually do use NLP in all those scenarios. And you can see, as just mentioned, a very commonly used case for NLP is actually the language is the question answering use case. And so you can see from time to time, we may ask questions for the machines to answer, and the questions could vary from one to another. For example, sometimes the question is quite simple, like just need a good laugh. It contains only 4 words for one question. But sometimes the question could be much more complicated, like what is the term for a task that lends itself to being solved by computer? So you can see actually the length of words in each question is very different from one to another. So that naturally brings the problem of input data with different shapes for our NLP model.
So as a developer, you will notice when you do like say image processing, you always have like a fixed size, right? You have to do all the padding to do recognitions and all that. Same thing with NLP. You always have dynamic inputs. And I think for this problem, we spent a lot of time at Intel trying to solve it, and I will hear more from it. That's great.
Yes, actually, Raymond. Besides the question answering and also the computer vision cases you just mentioned, another use case for NLP is, the name entity recognition, which we call the NER use case. It's that in this case, we input the text. It could be either a sentence or a whole paragraph that we need to identify or trying to recognize the key information, which we call the identities from the input text. So from here, you can see we can either input one sentence or a whole paragraph to identify the key information like location and time from the input text. So this is also commonly you could see that the input text length could be very different from one to another.
And
And
that's a very
so,
fundamental one for conversational AI too, right? I remember that.
yes, that's true. And so you can see that actually, if we don't have the dynamic shape feature, what we need to do is to pad a a bunch of redundant information to the input question. For example, so you can see for shorter question, we will actually pad a quite long sequence of redundant information. And for each question here in this page, you can see we need to pad different length of redundant information to the input to make them to a fixed length. And then we could input them to the NLP model. So of course, this padding of redundant, meaningless information will cause some impact on our performance of NLP model. And yes, also you can see here with the dynamic input shape, we already supported with our OpenVINO 2022.1. You can see that now we can actually input the exact length of words from our question into our NLP model. We do not need to do any padding at all for today. So you don't have to worry about the performance of the NLP being impacted by padding the information, the redundant information. And now, next, I would like to use a very simple example to show you how our OpenVINO could actually support that dynamic shape when we do the inference. And so you can see here, when we do the inference with OpenVINO, we need to import our OpenVINO runtime. And first, we need to load text. We need to analyze, and then we initialize the engine for our OpenVINO runtime. And then we define the model we need to do the inference on. And here comes the part that we tell our inference engine, tell our runtime that now we actually have the second dimension on our input that has dynamic input shape. So for example, here you can see, we now know that the upper limit of our NLP model has the length of 736 words. So we can use this kind of definition to tell our runtime that the second dimension has the dynamic shape, which has this kind of range. But also, if you don't know the maximum length of your input length, it doesn't matter. You can just allocate -1 to this input dimension, and that also works very well. And then you could continue to load the model to our device CPU. And that's how the dynamic shape is supported by our OpenVINO. So
some audience asks, can we get the slides? Yes. If not, take a screenshot of this, because this couple line of code is all it takes to run OpenVINO on Python. And I think I noticed very key messages here is like the dynamic shape is just basically that 2 lines of code there, right? That partials, and you define the actual input, right?
Yes,
that's great.
It's true. Yeah, it's just this 2 lines of code. And also, like you just mentioned, dynamic shapes not only exist for NLP, it also happens a lot for the computer vision case. So here, I would like to use an example of OCR to show how our OpenVINO supports a dynamic shape for computer vision cases. So as you know, OCR is actually to extract the text information from our uploaded image or from video. And so in OCR, actually, we did 2 parts of deep learning inference. The first part is text detection. The other part is text recognition. So for text detection, we actually locate where exactly the text is for each uploaded image. And then we use these rectangles, what we call bounding boxes, to locate the text location. And then after that, for text recognition, the input is just each image of the text of the bounding box from the text detection. And so you can see, due to the text would have different font sizes, and also each bounding box would include different lengths of words in it. So it is very natural that for each bounding box image, it will have different size. So as you also, I think you just mentioned, for if we don't have the dynamic input shape supported, we need to resize all the images to a fixed length. And that, of course, would also impact the performance. But now with dynamic input shape, we don't need to do the resize at all. We can just claim the dynamic shape like what we just showed with the 2 lines of codes. And that will also work for the computer vision cases.
So actually, that's very important, because we didn't talk about your background. You actually have done this before, am I right?
Yes,
like
yes.
You've done OCR and all that, right? And
Yes.
also, I think all the audience may not know, she's also a professor at one point. Am I right, too?
Yes, I was once
Yeah.
a professor.
Right.
Yeah.
Yeah, but for just that problem, I think as a developer, you notice when you're moving this kind of dynamic kind of like system, if you have to predefine everything, padding, it's just a lot of waste effort. So now, even for the programming perspective, it's a lot cleaner, and I like it. Let's keep going. But we have a question from the audience. The question is the model structure should be changed for the dynamic shape support?
I don't think so.
Do we have to
I
change
think
the model at all? No.
no. It is actually like the 2 lines of codes we just showed you. You just tell the
Yep.
runtime, our inference engine, which input dimension we have dynamic input shape, and
Yes.
that's all.
Yeah, you don't have to recompile the whole thing, retrain,
No.
nothing. That's the answer, right? Great. Let's keep moving and keep the question coming. I'm looking at the chat. Use the Q&A one, so that way I can help you even further. All right, let's keep going. Thank you.
Okay, and next I would also like to point out a very interesting and I think also useful pipeline for dynamic shape to working in. So you can see if we upload an image of a receipt, and first we can use OCR, which we, as mentioned, have dynamic input shape to extract the text information from the uploaded receipt image. And after that, we can also use an NER for NLP, also has dynamic input shape in it to actually link the actual text information to what it means. So for example, here it can link the date to actually the date on the receipt. And also it can link 35.50 euros as the actual money, total amount on this receipt. So after that, by using OCR plus NLP of NER together, we can actually digitize the text information from the input image and also structurize them and also output them
I
as a
heard you have a
JSON
demo for
format.
this.
Yes,
Right. You have
actually,
a
I
demo
have
for this. Am I right?
Yes, I think that's the time we should run the demos. I think this is how, like I just show you the overall pipeline. We have OCR to extract the text information, and also we have the NER to identify the entities we require to extract from the text information. But due to the time limitation for our session today, I will skip the OCR part. I will only show you when we input the extracted text from to the NER NLP model, how we can actually extract entities from that and output the JSON format. This is actually, we use one page. You can see we use just one page of Jupyter Notebook to show you how our OpenVINO can run the inference for entity extraction for name entity recognition. And as I just show you, that the overall workflow for this demo is quite actually simple, that we input the text we need to extract information entity from, and then we do some pre-processing to send the information, to send the input text to our NLP model, which we will use the small bird large-like model, which has been distilled and quantized by our OpenVINO. And then after some post-processing, we can see the extracted entities with the structured JSON format. And now let me restart the kernel and run all the codes from here, and I will walk you through the codes as we're running the codes. And so you can see here on the first step, we will do some essential packages import. And after that, we will need to download the model we actually need to use to run the inference with. And here, as just mentioned, this model that we use, BERT model, has been already included in our Open Model Zoo. So we can just use the OMZ downloader, this command, to downloading the model. So of course, for this demo, I've already downloaded model, so I will skip this part. And for next part is to load the model for entity extraction with dynamic shape. And here you can see that in this use case, we, on the second dimension of our input, we have the dynamic shape. And here we can just use this line to tell our runtime that the dimension on the second input shape have dynamic shape. And also, since we know that for this model, the maximum length of input is 384. So we will use this form of command to tell the runtime that this dynamic shape on the second input dimension is working in this way. And then we can continue to load the model to our device CPU. By the way, we can also print out the input names for this model, so we can know how we can prepare the input for the model. And then before we actually input the source text into our NLP for NER model, we will do some processing and define some pre- and post-processing functions. So as you know, NLP models usually takes a list of tokens as the standard input. And token is to convert each word of input to an integer by using a vocabulary. It works like a dictionary. So here you can see this is the vocabulary that we use to convert the actual words from our source text into integers, to convert them into a list of tokens, to input them into the NLP model. And besides that, we also need to define some specific tokens. Those two are used to denote this is the start of our input, and also this is the separator tokens to separate the two parts of our input. One part is for define which entities we need to extract, and the other part is the source text we need to extract entities from. And here is pre-processing. We prepare the input, where we prepare the input IDs to connect the two parts. We can prepare the attention mask, which is actually a sequence of integer values representing the mask of valid values for the input, and also the token type to show which part. For example, 0 stands for the entity tokens and 1 for the context part. So here is how we prepare the input. And from our inference results, actually, the results are just raw logits. So we also need to use the softmax function to convert actually the inference results to probabilities. And then we will look for the best entity extraction in the current part of the context with the highest probability. So this is how we can find the best entity and to find where it starts and where it ends. Well, finally, let's see.
Results. I'm so excited.
Yes.
So
and see,
what's the input and output look like?
Yes, so you can see before that, we need to define which entities we need to extract. So in our demo here, we want to extract like the building, the company, the city, this kind of entities. And here is our input. So in the first example, you can see we just input one sentence as our input text. And after running the inference, you can see here, we actually extract the information as company. Okay, Intel Corporation is being extracted as the entity of company, and Santa Clara as the city, California as the state. And also we can output a confidence score.
Right. So I think this is what we talk about conversational AI problem. A lot of time you ask the questions to a machine, it's like, where is something, right? Then it can extract, maybe you're asking about location, then you can say, oh, the city, the time. And this is also pretty fast, 0.2 of a second. So you ran this locally, am I right?
Yes, I run this locally just with my CPU. And the CPU is also doing some live streaming. So it's still pretty fast.
So maybe people already missed it. She just ran it live. So this is all just like ran on her own laptop. And yes. So let's look at more example here. What is the example about?
Yeah, this example is from when you input a whole paragraph of text. You can see this paragraph is quite long. And after running the inference, we can extract a bunch of entities from here. The building, company, city, state, height, all this could be recognized from the whole paragraph. And also it used just 300 milliseconds. It's also fast.
So I think to the developer, you notice like we have a lot of detail here. Don't worry, these notebooks is where you can download for free. We have it on something called the OpenVINO Notebooks GitHub repository, and I will share that to you already. So again, try yourself. You don't have to just watch it. You can even do it and have it running on your own laptop. So I have a couple more questions before we really move on to the next one. So for the demo just now, people ask like, what happens? You have multiple cities. Would it extract multiple of those, or just like it only extract one at a time?
It will extract multiple cities, of course. If your entity's name is just the city, it will extract them all.
So we're not limited to only one thing at a time. That's great. Now, okay, a lot of people ask this question. If we're doing this dynamic shade, are we gonna get like a very dramatic improvement in terms of the performance, or what's happening there behind the scene?
First, I think because we don't need to do the padding to the NLP model or do the resize for the computer vision model. So of course you can see the inference could be fast. And also since you can see that during the padding or during the resizing, some of the information may be lost or be impacted. So of course that could be avoided by using our dynamic shape feature.
Right. So the pre-processing will be saved. And I think for a lot of us that use computer vision, you spend enough time resizing things all the time. That extra line of code is now gone. I think it's already that boost that you'll get. So the people keep asking, like, how can I even get better speed? That's why I think try yourself. We have different way of optimizing. And at the rest of the conference, we'll talk about different methods that we can even use to boost it even better. Right now, I have one last question from the audience. They ask, what's NER? I know we have a lot of acronym, OCR, NLP, NER. What's the NER here?
Okay, I will. I will try to explain a bit more. NER is like name entity recognition. So it's kind of like to identify entities, like the key information you want to find from a bunch of words, from a sentence, from a paragraph. So what I showed in the previous example, you have input a whole paragraph of words, but you only want to identify the key information, which may be just the location, maybe just the time in all those words. So when you do the NER, it can extract the information, the key information you are concerning very quickly.
Right. And OCR, I'll answer this one. It's a bit easier. It's one of the very first one you learn, optical character recognition. So this is where I think very long time ago we started with, let's say, mailing. Back then, there's the people read the number, read the address. Now it's done by machine. It's that problem that we're trying to solve there. And there's another one called text spotting. It's anyone basically, you have a piece of paper, you want to find out where is the text, right? So those are the terms that we basically described today. And hopefully you'll learn a bit about why this is an important field, because imagine now you can read many things on the real world. Now you can virtualize things, or you can just like get the information to the next person much faster. And trust me, you don't want to be the human optical character recognition person. And you know it's a very tedious job sometimes. All right, so what's next? What should we do? We said try ourselves. How do I try that?
Actually, you can find all those sample codes, just like what I showed in our Jupyter Notebook demo. You can find them on our open source GitHub repo, just like the one we showed here. Just the OpenVINO notebooks, you can see that you can clone all the sample codes from our repo here. And for the NER live demo, you can find it in our in our notebook 204. And the OCR demos we just talked about could be found in 209 and 405. And also, like the question answering, this very popular, commonly used use case for NLP could be found in notebook 213.
So these number basically means when you go to our sample code, we try our best to put a number in front of it so you can look up each of them quickly. So when you go to the repository, look at the source code, you have that index for you. We try really hard to give you more sample. If any more requests, come and ask us. That's why we're here at Intel. Next.
I think next is that I really encourage you to try all those notebooks yours and tell us what's your inference speed is.
Yeah. Well, so for all of you here listening today, we have an AI challenge coming up. That's the time where you can win off the hoodies or some of the small prizes we're giving out. So stay tuned for the coming up sessions. And Joe will be on the next session as well to talk about something that you should also know, auto plugin. So coming up soon, and thank you, everyone.